All right, taking a look at a video this time dealing with the basics of geometry, the basic shapes and the things that are used as we get ready going on there. So we're going to take a look at the nature of the beasts. We're going to look at lines and how you name them. We're going to look at planes and how you name them, and angles and how you name them, and then spaces and kind of sort of how you name them, and we'll go from there. All right. So first of all, the nature of the beast. Everything begins with the whole concept or the idea of a point. On a piece of paper, we use a dot to represent a point. The definition, or the best definition I can think of in a regular vernacular, is a point is just simply a location. A point is a size that you need it to be. So for example, on my board, a point might be a pixel. You can't see those in the camera, but I got a lot of little pixels here I can see from this perspective. But if you're out in the middle of the universe somewhere, then the Earth itself could be a point, or even the sun could be a point, even though it's way larger, obviously, than the pixels that are currently on my screen. So a point is a location, and its size depends on what it is that your perspective happens to be in whatever it is that you're working with or whatever it is that you're working on. They don't have any size. They're called zero-dimensional. They have no length, no width, and no height. So technically you can't draw them. Technically this has a length and a height on it, so I could actually measure the area of this space. A point doesn't have space, it doesn't have volume, it doesn't have length, it doesn't have width, it doesn't have anything of that nature. It's just simply a location. Now, when you start stringing a bunch of points together, now I can get this idea of, well, how far is it this way from here to there? And so therefore we add in this idea of a length, and length is the first dimension. Now, this begins to form the idea of a segment as a series of points heading in the same direction, or a line, or a ray, or something of that nature. So these things have length, but they don't have anything else. They don't have width, they don't have area, they don't have volume. Even though they're on here, technically they're two-dimensional the way that they're being drawn on the screen. A real line or ray or segment wouldn't have any thickness, but we have no other way to represent that on the paper. So it does have a minuscule bit based on my pen. And so that dimension comes into consideration there. All right. So then if we start moving off in a different direction, in the direction that those points are already moving, and begin to come this way, now we've added a second dimension. Not only do we have length going in one direction, but we now also have width heading off in another direction. Those are two dimensions. These dimensions are right angles to each other. Okay, they form a 90-degree angle. They're perpendicular to each other. And so this is now two-dimensional, but these dimensions are perpendicular. So what if I had a segment and one not coming off? Or this is still two-dimensional, because whatever I consider to be my length, the width is going to come off of that in a perpendicular manner, even if the segment itself is not coming off perpendicular. This is still a two-dimensional shape that's being presented here. Now, third-dimensional I can't draw on the screen. Third-dimensional would be something that's coming off the screen. So if I took this drawing that I have going right here, and I worked in this area, and then I came straight up off this at a 90-degree angle, that would then be height. Length, width, and height are then three dimensions. These guys have volume, they can have area, they can have length. These guys can only have area and length. These guys can only have length. And these guys, points, have nothing. No dimensions whatsoever. Now before I move on to the next screen, I need to tell you one more thing. And that is, points are named by a single capital letter. So if I have a point, they're named by A or B or X or whatever the case happens to be. They're named by a single capital letter. That's the easiest one to remember, because it's the only way to name a point, is to go in that case. All right. So the next thing is, well, what about lines? Lines, as we said, have one dimension. They're a series of points moving along, so on and so forth. If they go on forever in both directions, then it is called a line. If it goes on forever only in one direction, then it is called a ray. And if it doesn't move on forever in either direction, then it is called a segment. A segment has a length I can measure. A ray has an infinite length, and line also has an infinite length. little bit more vocabulary to worry about here is if you have a segment or array, then you have a thing called an endpoint. If you have another endpoint, and then this is the series of points on the inside. To go from one point to the next means you only have to move at all. So there's an infinite number of points on a segment between this point and that one, no matter how short it is, even if the segment's that short. There's an infinite number of points there because I can get down very, very microscopically minuscule to be able to move from one place to the next. The next thing about lines is that they can be named, and they have 3 different symbols, and they actually have 2 different ways of being named. So way number 1 to name these things is to name it by 2 points that make up a line. Now a line is defined by 2 points. I'm going to explain that real quick before we get into the naming because there's a reason why I have to have 2 points. If I just have a single point, there are an infinite number of lines that can run through this point. I could be going in that direction, I could be going this direction, I could be going in all kinds of different directions, an infinite number of directions. But as soon as I have a second point, I now have a defined from here to there type idea on what's going to be happening here. So 2 points, say A and B, define a line, array, or a segment. If this goes on forever, that's array at this point, and now it's become a line as I draw on that other side there. So these 2 points define, go start here and go through there. If I only have 1 point, that's not good enough. So I have 3 different ways to deal with this segment I drew here. The first one would be segment AB. Notice that this doesn't have any arrows on it. This means segment AB. This means the segment from A to B. This is the same as segment BA. These 2 are identical notation. They mean exactly the same thing. Number 2, we can have ray AB. That means the ray starting at A and heading off through B. This does not equal ray BA. This means start at B and head through A. These are different rays. Now they're heading along the same pathways, one going this way, one going that way, but these are not the same thing like they are with segments. The last piece is I could have line AB. That is the same as line BA. Those 2 are the same because they describe the same objects. So those are your ways to name segments, lines, and rays. There is another way, just to mention real quick. Any straight object, whether it be a line, array, or a segment, can be named by a single lowercase letter, often using J or K or something of that nature. If we say ray J, that's just named by 1 line. I don't know what the points are that define it. Here in this case I know what the points are that define it. So that's segments, lines, and rays, 1-dimensional objects. Moving on to 2-dimensional objects. Now my screen actually is a 2-dimensional object. The tabletop, the ceiling, the wall, or my computer screen, or whatever the case is, all those things are 2-dimensional objects because they have a length and they have a width that are involved in each one of those things. Now, in the same manner, that a line has a certain number of points it needs to be defined. A plane has a certain number of points it needs to be defined as well. It needs 3. Kind of like a stool. If you set a stool on the floor, and you need 3 legs in order for it to be able to balance itself. If you only had 2 legs on a stool, it would flop this way or that way. If you had 1 leg on a stool, without a big base or anything like that, if you just had a single stick or whatever as a leg, then it's going to fall over in any possible direction. If you have 2 legs, it's going to flop in 2 directions. And you put a 3rd leg on there, now it has the ability to be able to stand up straight. Well, a plane in the same manner, what that does is it defines the plane. For the stool, it defines, here are the 3 points sitting on this surface, defines where the stool is able to sit. So a plane can be defined by 3 points that are non-collinear. And what we mean by the word collinear is that they are not on the same line. Co means together, linear means on the same line. So together on the same line. You can also use that with coplanar. This would mean things that are together on the same plane. These 3 points can define a plane. Drawing that is technically impossible, but there it is anyway. And it can be named by the 3 points, so we can call this plane X, Y, Z is one way to name this thing. What if there's another point? Then that's fine. You can throw in more letters, but normally go by 3 that define it. Planes can also be named by a single kind of boldish capital letter. So this could be plane R. This is different than a regular point. If I had a point R, I'd write it as a regular R. Here we add this little extra thingy on there to indicate that it's bold, italicized, or something of that nature to say that this is plane R. So there are two ways to name planes. One is by 3 points that define that plane. We introduced the word collinear, which means that they are non-collinear, which means they're not on the same line. And then we can also name it by a single capital letter. Anything else that's a plane in here has 3 points that would allow us to be able to define where that plane is. All right. So moving on now to angles. Angles are a little bit more complicated. Angles can be named in several different ways. The main way to be able to name an angle is by 3 points. A point that is on one side, a point that is at the vertex, and then a point that is on another side. So if I said A, B, C, I could call this angle ABC, or I could call it angle CBA. These are equal names for my angle that I have shown here. The B needs to be in the middle. The vertex of the angle is this angle, so that means start at A, go to B, make your turn, and then head off to C. So if I said this is angle BCA, does not represent the angle that's drawn there on the board. Angle BCA would rather be the angle here, turning at C, and then heading off to A, so that'd be the blue one. BCA would be the blue angle that I have drawn there. All right. So let's draw another one here. Show you another way to name these things. Call this X, Y, Z. You can call this angle Y, meaning just naming it by its vertex, but there is a caveat to this particular piece of information. You can only name it angle Y if that's the only angle there. Now here's what I mean by that. This is legal right now to be able to call this angle Y, but as soon as I do this, and throw on point A, or ray YA, you can now no longer call this situation angle Y. You can say the angle's around vertex Y, but there are 3 angles here. There's 1, 2, and then the whole one's 3. If I call this angle Y, which one are you talking about? Are you talking about the left, the top one, the bottom one, or the whole thing? Can't call that Y. Now in this situation you have to call it by its 3 letters, or by another convention that you'll see used often. You might name an angle by a number. So we might name that angle 1, might name that angle 2, and then draw on here and say this is angle 3. It's okay to say angle 1, angle 2, and angle 3 in this case. So you can name it by its 3 letters, 1 letter on each side with the vertex in the middle. You can name it by its vertex if it's the only angle at the vertex. And then you can also name it by a little numbering system with the numbers drawn on the inside there. So that's the angle stuff. The last piece of the puzzle is spaces. There's not really necessarily a way to name this. A space is a 3-dimensional shape. It is defined by a certain number of things. It takes 4 points to define a space, 3 points to define a plane, so there's a flat surface that can go through any 3 points that are non-collinear. I need a 4th point. In this case, it'd be 1 up off the board. In order to, now drawing's not going to be very good, but if I was trying to draw kind of a pyramid-y-like thing here, I'm already not doing well on this, but that's okay. That's a space. That's the minimum number of points you need to be able to define a space, because each of those pairs of 3 points can define a plane that would then enclose the space. Generally speaking, we don't really name spaces. Space is just kind of the set of all points that are out there. It could be the universe. There's an infinite number of points as you move away from a particular place or whatever. So spaces, the only thing I really need you to know about spaces is that if you want to define an enclosed space, meaning enclosed by planes, you need 4 points. 3 points define one plane. That 4th point then divides defines the other planes that are there to be able to enclose the space. All right? So that's the basic general stuff that you need to know about the basic geometric objects. Points, lines, planes, angles, and spaces. Those are the universe in which geometry functions. Until next time, see ya!